0. Okay, this means that again when we say 1234, we are using the basis of 10. Look at here, this is the first, this is the second, and also this is the third, and also this is the fourth. Okay, this means that in the real world we are using the decimal. This is the decimal. Okay, and the decimal is the easiest method for us for using in the normal communication or normal numbers in the real world. This is the selected basis that we are using, decimal. But in the computer world we are using another basis, binary. Okay, in decimal, as you know, in decimal value, let me to write here, in decimal value we are using this number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These values, okay, are the numbers that we can use in decimal, okay, in decimal word. But here we have another word, another basis of the IP of the addressing. We call it binary. In binary we have only 0 and 1. And when you say that I am using the binary basis, this means that you are talking about the basis of the 2. Okay, 2 to the power of something. Let me to give you one example for better understanding. Assume that we have 156 in the base of 10. You know that this is the base of 10. Here we can use the parentheses, and after that we have an annex. Here this means that 156 with the annex of 10. Now the question is that how you can convert this value, okay, to the binary. Okay, and binary is the base of 2. This is the binary. When you say binary, means I am using the base of 2. You need to write this value in the power of 2. What is the power of 2? Let me to review this for you. 2 to the power of 0, okay, equal 1. 2 to the power of, for example, 1 equal 2. Or 2 to the power of 2 is equal 4. 2 to the power of 3 is equal to the 8. You know it. 2 to the power of, for example, 4 equal to 16. 2 to the power of 5 equal to 32. Okay, 2 power of 5 equal to 32. Then 2 to the power of 6 equal 64. 2 to power of 7 equal to 128, and so on. Okay, how you can write the 156 in the power of 2? Okay, for example, we can say the 156 equal to the 128 means a 2 to power of 7. Okay, we don't use 2 to the power of 6 because if you add this value to the 128 you have a bigger value than the 156. But if you use the 2 to the power of 5, 32, totally you will have 160. Because of that, again, I'm not going to use this value, but we can use this value. 128 plus 16 equal is 144. Okay, again I can add the 8, 152 is the total. Okay, and after that we have a 4. Let me to add this value to each other. 128 plus 16 equals to 144. Okay, plus 8, 152, plus 4, 156. This means that if you want to use the binary values for creating the 156, you can use 1, okay, 1, 2 to the power of 7. Okay, let me to write here 1 multiply, I can use here 1 multiply 2 to the power of 7. Okay, this is the first value, and you know that we don't want to the power of 6 to power of 6. Because of that, let me to use 0 to the power multiply to the power of 6. And then also, as you saw, I didn't use 32 because of that 0 to the power of 5, but I used the 2 to the power of 4. Because of that, we need 1 multiply to the power of 4, and also I used to the power of 3. Because of that, we need 1 multiply to the power of 3, and also I used to the power of 2. Because of that, we need 1 multiply to the power of 2. I didn't use 2 to the power of 1 because of that. Let me to use 0, 2 to the power of 1. Okay, and after that I didn't use the 2 power of 0 because of that. Let me to use 0, 2 to the power of 0. That's it. Okay, now this is the binary, for example, values of the 156. When you know that when we are using the decimal, we use these values, okay, for the decimal value 156, 156, also 1234, and these are the factors of the power of tens. The factor of power of tens is 1, 5, 6. Here is 1, 2, 3, 4. Okay, here also we need to use the factors of the power of 2s. For example, when you want to write the power of 2, here we have the 1, the first factor, and also and the next is 0. After that the next is 0, then 1, then 1, then 1, 0, 0. Okay, this is the binary value of the 156. Look at here, 1 multiplied to the power of 7, 0 multiplied to power of 6, 0 to the multiplied to 2 power of 5. Okay, again 1 multiplied to the power of 4, 1 multiplied to 2 power of 3, and 1 plus 1 multiplied to the power of 2, and 0 multiplied to the power of 1, and 0 multiplied to the power of 0. This is the binary value if you use the factors. Here I use the factors. Here we have 8 bits, 1, 0, 1, 1, 1, 1. As you can see here, we are using only the 1 and 0 because of that. This is binary. When you say that I'm using the binary basis, this means that you are using only the 0 and 1 in your number. Also, after that, you are using the factors of the power of 2. Let me to give you another example. These examples are important for us, but before that, look at here, decimal to binary conversion. A base exponent 2 to power of 7 is equal to the 128 to the power of 6, equal to the 64, as I mentioned before, 2 to power of 5, 32 to the power of 4, 16 to the power of 3, 8 to the power of 2, 4 to the power of 1, 2 and 2 to power of 0 is 1. And here we can see the conversion of 35. Let me to use the conversion of 35 here. Now we can easily calculate the 35. You know that in 35, okay, we don't have for example 128. Because of that, let me to use 0. This is the factor. And after that, we don't use the 2 to power of 6, 0. We have only 1 to the power of 5 means 32. Now we have only 3 value, because if you for example subtract the 32 from 35, we have only 3. We don't need 16, we don't need 8, we don't need 4, but we need 1 2 to power of 1, and also 1 to power of 0. Let me to add this value to each other. Here we have 32, also we have 2, and here we have 1. If you add these values to each other, now you have 35. This means that the equivalent of the 35 in the power of 10 is 0, 0, 1, 0, 0, 0, 1, 1, okay, to the power of 2. Okay, this is the conversions of the bases. This is so important that you can do this function. Maybe in first scenarios this is a little difficult for you, but after some examples, after doing some examples, you can easily convert the binary to decimal or decimal to binary. I will give you another example to better understanding the conversion between the binary and decimal. This is the basis of this course. Because of that, you need to learn this function so good, and after that you will use it. Let me to give you some for example examples. First number is 255. Okay, 255 in the power of 10 equivalent to which value in the power of 2? This is the first question. Okay, let me to calculate this 255 in the power of 10 to a value in the power of 2. But I'm not going to again writing all of the for example details of the previous scenario. I'm using only this value.